Hello, 7.1, 7.2 exponential growth and exponential decay graphing video. This is the first of two, and we are going to learn in this video how to graph. The easiest way to explain exponential growth and exponential decay is the most recent incident on the Royal Caribbean cruise line, where the rotavirus went through like a fire. So in a constant growth, a linear function, 5 people would have it Monday, another 5 would get it Tuesday, another 5 would get it Wednesday, but we know that's not how it works. So I tried to find the news clip, but they actually did a really good visual. Let's say the first day had it 5, the next day 25 had it. The next day 625 had it. The next day 625 squared had it. So that is exponential growth. There are lots of things that grow exponentially. Putting money in a bank with an interest rate, that grows exponentially. The value of an antique grows exponentially. There are also things that decrease exponentially, like depreciation of a car, etc. Okay, so let's first start looking at exponential growth. The standard form of growth is y equals a times b to the x minus h plus k. Notice the a, h, and k that we've been talking about now for so many weeks. A is your stretch factor, h is your left and right, and k is your up and down, your vertical stretch. So in growth, the b must be greater than 1. So it has to be positive and greater than 1. So let's look at this first graph. The first thing you want to do is you want to go ahead and make sure that you know what your a and your b is. And remember that b is always directly attached to the x. So right here, 2 is my b. So my question is, what is the a? And if you are thinking 1, then you are right. This is really 1 times 2 to the x. So let's pick numbers to plug in. Let's start down here on the bottom and let's do 2. So 1 times 2 squared is 4. Let's plug in 1. 1 times 2 to the first is 2. Let's plug in 0. 1 times 2 to the 0. If you remember back to exponents, anything to the 0 is 1. So 1 times 1 is 1. Let's plug in negative 1. Exponent to the negative, remember, 2 to the negative 1 would be 1 over 2 to the positive 1, so 1 times 1/2. Let's go ahead and plot those points. So negative 1, 1/2, 0, 1, 1, 2, and 2, 4. Okay, so I know it stretches up this way, and I want you to think if there's a negative number that I can put in for x that would actually give me 0 or a negative number. There isn't, so I will never have an x, an input that gives me an output of 0. So what that means is that I will approach an asymptote which is right here on the x-axis, and the equation of that asymptote is y equals 0. My domain obviously is all real numbers, negative infinity to positive infinity. Now range, the bottom is 0, the top is positive infinity, but I won't ever touch 0. So that would be my domain and range. Now I want to point out a pattern here, and the pattern might be difficult for some of you to grasp. So I want you to play this again because I want you to completely understand. What we're going to require on your graphs are 3 numbers. We're going to want you to input negative 1, 0, and 1. And if you think about this, I'm going to start at 1. If I plug 1 into the x, into that x, 3 to the 1 is going to be 3, which is b, and then I'm going to multiply it by the negative 2, which is going to give me negative 6. Okay, so notice when I plug 1 in, no matter what this is in here, it's going to end up being this number, which is b, and then I multiply times a. So 1 will always have the pattern a times b. Okay, Now let's consider plugging 0 in. Anything to the 0 is 1. 1 times the a is going to be negative 2. So whenever I plug 0 in, the answer is going to be a. And lastly, if I plug in negative 1, I'm going to be 1/3. So a times 1 over b is going to be negative 2/3. And it will be a times 1 over b. And if I plot these, negative 1, negative 2/3, 0, negative 2, and 1, negative 6, again, I won't be able to create 0, so I will have an asymptote, and we will expect to see these asymptotes graphed on every graph. The equation of the asymptote will again be y equals 0. Domain is negative infinity to positive infinity. Range is from the bottom to the top, not included. So now we're going to be looking at decay, and the only change in this is that b is going to be between 0 and 1. It cannot be negative. It must be between 0 and 1, which means, in essence, a fraction that is less than 1. So remember the pattern that we just discovered. If I plug negative 1 into any of these, the y will be a times 1 over b. If I plug in 0 to any of these, the y will be a. And if I plug in 1 to any of these, the y is going to be ab. So I'm going to plug in negative 1, 0, and 1. If I plug in negative 1, my y is a, 2, times 1 over b, which is going to be 2. So it's going to be 4. Negative 1, 4. If I plug in 0, it's just going to be a, 0, 2. Obviously, a is going to be my y-intercept. And when I plug in 1, it's a times b, so that's going to give me 1. Okay, if I plug in 2, I'm just going to go one further so you can see what happens. I'm going to multiply 2 times 1/2 squared, which is 1/4. 2 times 1/4 gives me 1/2. So you can see that this graph is steadily decreasing, but again, there is no x that you can input to get an output of 0. So again, we have an asymptote along 0 where this graph cannot cross. The equation of the asymptote is y equals 0. My domain is all reals, negative infinity to positive infinity. My range is from 0 to positive infinity. Over here, let's make sure we remember that a here is negative 1. So I'm going to plot negative 1, 0, and 1. So negative 1 is a times 1 over b. So that's going to be negative 1 times 6 over 1. I'm going to plot 0, which is a. And I'm going to plot x equals 1. If I plug in 1, I'm going to multiply a times b, so negative 1, 6. So if I plug this in, let's extend this graph a little more, I have 1, negative 6, 0, negative 1. Notice again my a is going to be my y-intercept, and 1, negative 1/6. And my graph be like this. Domain, negative infinity to positive infinity. Range, bottom to top. Do not turn that around. Okay, so now introducing A, H, and K. We've really been dealing with A, so to add H and K is really not a big deal. We're going to stay with the same plan. We're going to plot negative 1, 0, and 1. So negative 1 is A times 1 over B. So A here is negative 1, B here is 3. So A, negative 1 times 1 over 3 would give me negative 1/3. If I plug in 0, it's just A. If I plug in 1, it's A times B. A times B would give me negative 3. Negative 1, negative 1/3. Be here. 0, negative 1 would be here, and 1, negative 3 would be here. But now I have to take into effect the H and the K. So the H and the K. And remember this X, if it's a minus 2, we go plus 2. So I'm going to take every X and go forward 2, and then it's positive 3, up 3. 1, 2, 3. I'm going to take this one, go forward 2, and up 3. Take this last one and go forward 2, and up 3. Now, if everything shifts up, then so does my asymptote. So my asymptote goes to positive 3. So y equals 3, and my graph would come here. Okay, so my domain is negative infinity to positive infinity, and range is from negative infinity to positive 3 this time, but does not include it. Same thing over here, real quick. We're going to do negative 1, 0, and 1. If I plug in negative 1, I'm ignoring the h and the k right now. Negative 1 is a times 1 over b, so it's going to be 9 halves. Plug in 0, it's just a. Plug in 1, it's a times b. That's 4.5. So now 4.5 is going to be here. 0, 3, and 1, 2. Okay, I can tell by my B, don't forget that your B tells you if it's growth or decay. I can tell by my B that this is decay. I'm going to take each X and I'm going to go backwards 1 and down 2. Backwards 1 and down 2. 2. Backwards 1 and down 2. Backwards 1 and down 2. My asymptote also, y equals negative 2. And here's my graph. Domain, negative infinity to positive infinity. Range, negative 2 to positive infinity. Last but not least, we're going to write the equation of an exponential. This obviously is a growth. We have 2 points, 0, 1/2, and 1, 3. And if you remember from what I was saying before, I know that 0, 1/2 is always my 0a. So I know that a is 1/2 because it's the y-intercept. Okay, I see that I'm not doing any shifting because my asymptote is at 0. So I know the equation is y equals a times b to the x. If I plug in y equals a times b to the x, now I take my other point, y equals a times b to the x, multiply both sides by 2. Excuse me, that x is 1, isn't it? I get b to the 1 is 6, so b equals 6. I now must write the equation, so y equals a times b to the x, and that would be the equation of this. Okay? The other thing you can do, if you're following the rule, remember 0 is always with a, and 1 is with ab if there is no shifting. So if a is 1/2, this would be 0, 1/2. And I know that this is 1, 1/2 times b, and it goes with the point 1, 3. So 1/2 b equals 3, so b equals 6. Either way works, and we will be working on these in class tomorrow.